Neetu Balachandran, teaching faculty from Christ College of Engineering in Nalagoda. Here we are going to discuss the previous year KEAM question papers of Physics Paper 1. In this video, we will be discussing mainly the questions from electrodynamics. So let's begin the class with the syllabus of electrodynamics. The syllabus includes the electrostatics, current electricity, magnetic effects of current and magnetism, electromagnetic induction and alternating currents, electromagnetic waves, capacitance. Okay, these are the syllabus. So let's start discussing the questions. The first question is, a point dipole with a dipole moment P equal to P0 K is kept at origin. An external electric field E equal to E0 2I minus 3J plus 4K is applied on it. Which one of the following statement is true? The statements are, the first one, the force on the dipole is 0 while the torque rotate the dipole on xy plane. The second statement is, the force on the dipole moves it along the direction of the electric field. The third one is, the interaction energy between the dipole and the electric field is 0. The fourth one is, the potential due to the dipole alone on xy plane with z equal to 0 depends on the value of P0. And the last one is, the application of the electric field orient the dipole along minus 5k direction. Let's see how to solve how to conclude the answer. The answer is A. Let's see how to conclude the answer. So, in a uniform electric field, when dipole is placed as described in the question, we can represent it in the simply like the figure. Okay, so you can see the dipole is along the z-axis. Since it is a uniform field, the force acting on the dipole will be 0. That is, the linear force is 0. But there is a torque acting on the dipole. The equation for the torque acting on the dipole is τ is equal to P cross E. Let's see the determinant form of this particular equation. So in this form, you can see that. So this is a determinant form. We have ijk 00p0 2 minus 3 4. While calculating the cross product of P and E, we can see that here we have 2 zeros. So the K component will be absent in this equation. Okay, the K component is absent means the torque rotates the dipole in xy plane. That is, the answer is the force on the dipole is 0 while torque rotates the dipole on xy plane. Second question is, find the total capacitance and total charge on the capacitors. The circuit is given. These are the 5 options. Let's calculate the answer. So the answer is A. Okay. So now we have, in the previous figure, we have 2 parallel capacitors. So the effective capacitance is C1 plus C2, which is equal to 1 nanofarad plus 2 nanofarad, which is equal to 3 nanofarad. Now the equivalent circuit is given as in the picture. So now we have 2 capacitors of 3 nanofarad, which is connected in series with the battery 6 volt. Okay, now in the circuit, the effective capacitance is, since these are of same values, so the effective capacitance will be the value of the capacitor divided by the number of capacitors, that is 3 nanofarad divided by 2, which is equal to 1.5 nanofarad. So that is the total capacitance of the circuit. Next thing is to calculate the charge on the capacitor. To calculate the charge on the capacitor, consider the equation. Q is equal to the total capacitance into the input voltage. Substituting the values, we will be getting 9 nanocoulomb. That is, the total capacitance is 1.5 nanofarad and the total charge on the capacitor is 9 nanocoulomb. Another question is, the resistor R1, which is equal to 3 ohm, R2 is equal to 1 ohm, connected in parallel to a 20 volt battery. Find the heat developed in the resistor R1 in 1 minute. We have 5 options. These are the options. Now the answer is D, which is 8000 joule. Now let's see how the circuit is looking like. I have represented a circuit here as per the question. We have two resistors which is connected in parallel and it is connected to a 20 volt supply. So the effective resistance in this case will be 1 by R1 plus 1 by R2 which is equal to 3 by 4. The effective resistance in this 3 by 4, the equivalent circuit of this particular is we have a resistor of 3 by 4 ohm connected to a 20 volt supply. Okay, that is the effective resistors. Now let's see the total current flowing through the circuit is the input supply which is 20 volt divided by the effective resistance which is equal to 3 by 4. So we will be getting 20 into 4 divided by 3 ampere. Okay, the question is to calculate the heat. Okay, the heat developed by R1. To find this particular answer, now consider the equation, that is the heat flowing, the current flowing through the resistor 3 ohm, that is this one R1, which is equal to the other resistance 1 ohm divided by the total resistance into the total current. Okay, the other resistor divided by the total resistance into the total current, which is equal to 1 by 4 into 20 into 4 by 3, that is the total current as per this equation, which is equal to 20 by 3 ampere. That is the current flowing through the resistance R1, that is 3 ohm. The question is to calculate the heat developed. The heat developed is H is equal to I square RT, substituting the value of I square and R and T, we have 8000 joule. Another question is, a circuit is made using R1, R2, R3, R4 and a battery as shown in the following figure. Find the equivalent resistance of a given circuit and current passing through R3. That is the question. The circuit is given. The circuit is this, and we have our second option, third option, fourth option, fifth option. Okay, these are our 5 options. So let's calculate the answer. The answer is B. Now we have the circuit which consists of 4 resistors, okay, and which is connected to a 27 volt battery. From these 2 points, okay, the circuit can be redrawn like this. Okay, so this is R1 plus R2. The effective resistance is 0.5 ohm plus 0.5 ohm, which is equal to 1 ohm, and R3 which is 1 ohm and R4 is 1 ohm. So now the circuit is like this. Okay, so the equivalent resistance is we have 3 same value resistors, right? In this circuit we have 3 same value resistance. So the value of the resistance divided by the number of resistors, since it is parallel, so it is equal to R by N, which is equal to 1 by 3 ohm. So that is the equivalent resistance or the effective resistance of the circuit. So the total current flowing through the circuit is the total current flowing through a circuit is EM of total division divided by the effective resistance, which is equal to 27, that is the input, divided by 1 by 3, we will be getting 27 into 3. Okay. So the total current, which is equal to 3 times the current flowing through I3. The total current is equal to 3 times the current flowing through this is R3. So that is I have represented the current flowing through R3 is I3. That is the total current is equal to 3 into I3. Therefore I3 is equal to the total current divided by 3, which is equal to 27 ampere. Okay, 27 ampere is the current flowing through the resistor. Now, and the total current flowing through the circuit is 27 ampere. Let's see the next question. A point charge plus Q is held at rest at point P. Another point charge minus Q, whose mass is m, moves at a constant velocity v in a circular orbit of radius r1 around P. The work required to increase the radius of revolution of minus Q from r1 to another orbit r2 is. So we need to find the work done. So it is given that R2 is greater than R1. These are the 5 options. Okay. Now the answer is D. Let's represent the question in a figure. So here this is the point P. I have a plus Q charge here and I have a minus Q charge here. the plus q charge is at the center of the figure and minus q is orbiting the plus q charge at a radius r1. So this problem can be solved, that is we have the equation, Coulomb's force equation. So the force between these two charges can be represented as, according to Coulomb's equation, that is K is 1 by 4 pi epsilon 0. Force is equal to K into Q into minus Q divided by R square. The question is to find the work done. The work done is equal to, that is the work done required to increase the radius of minus q from r1 to r2, which is equal to integral of the initial radius to the final radius f dot dr, which is equal to integral of r1 to r2 k into q into minus q divided by r square dr. So we will be getting minus k into q divided into 1 by r2 minus 1 by r1. So the work required to increase the radius of revolution of minus q from r1 to r2 is k into q 1 by r2 minus 1 by r1. Okay. Now, another question. A particle of charge q moves with a velocity v, which is equal to ai, ith direction, in the magnetic field equal to bi plus ck, where a, b, c are constants. The magnitude of the force experienced by the particle is. Okay, this problem can be solved by the Lorentz force equation. The answer is C. This problem can be solved by the Lorentz force equation. We know the Lorentz force equation, which is F is equal to Q into V cross B. Okay, now V is the velocity. V is the velocity, which is equal to A into I. B is the magnetic field, which is equal to Bj plus Ck, and Q, which is equal to capital Q. That is given in the question. Okay, now let's substitute all these values into the Lorentz force equation. So we will be getting Q is equal to ABK minus ACJ, since we know that I cross J is equal to K and I cross K is equal to minus J. So we will be getting this answer. Okay, so the question is to find the magnitude of the force. Okay, to find the magnitude of the force, we need to take the modulus of the force, which is equal to modulus of F is equal to Q into root of AB square plus AC square, which is equal to Q into A root of B square plus C square. That is, the magnitude of the force experienced by a particle is Q into A root of B square plus C square. Next question is, find the voltage and current passing through a resistor R2 shown in the following circuit. This is the circuit. We have two resistors which is connected parallel, and another one, R1 is 3 ohm, is also connected, and everything is connected to an 8-volt supply. Okay, and these are our 5 options. The answer is E. Since these R2 and R3 is connected parallelly, so we can also which are equal values. Okay, both are 2 ohm. So we can take the effective resistance, which is equal to R by N, which is equal to 2 by 2, which is equal to 1 ohm. Okay, that is, the effective resistance is 1 ohm in that parallel case. Okay, now the circuit become 2 resistors, 3 ohm and 1 ohm, which is connected in series. Okay, and the equivalent resistance, equivalent circuit is also given here. Now then, the potential across 1 ohm, which is equal to, the potential across 1 ohm is equal to 1 ohm divided by 3 plus 1 ohm, that is the total resistance, into 8, which is equal to 2 volt. That is the potential across that R2. Okay, that is the potential across that 1 ohm is 2 volt. Now we need to calculate the current, the total current. The total current is equal to the input voltage divided by the total resistance, which is equal to 4 ohm. That is, we getting 2 ampere is the total current. Now see the circuit, you know, this is a circuit. Now the current is passing through 2 equal resistors. Okay, the current is passing through 2 equal resistors. So the current will be divided into equal values. That is, 2 ampere will be divided into 1 ampere and 1 ampere. So the voltage and the current passing through the resistor R2 is 2 volt and 1 ampere. Okay, so in the coming video also I will be discussing the questions from electrodynamics. I hope you understood the concept. I hope you understood the answers also. If you have any doubt, you can comment or you can directly contact me. And wish you all the best for your examinations. Thank you.